Hello dear student, how are you? I hope you are all will be fine. I'm also fine, thank you. Welcome to your channel. It is today lecture number 13 of nucleophilic substitution reaction. And today lecture we will be in previous lecture we studied about the Sn1 reaction and Sn2 reaction in very details. So in today lecture we will be we will be differentiate what is the difference and similarity between Sn1 and Sn2. So in today lecture we will be study the comparison between Sn1 and Sn2 reaction. Comparison between Sn2 and Sn1 reaction. Sn1 versus Sn2 reaction. Today we will be study this. Before I start the topic, first you should know that alkyl halide reaction, the reaction of alkyl halide, Sn1 and Sn2 reaction are maybe like that. It will be like that. If that is alkyl halide, if when there is alkyl halide plus nucleophile in the presence of nucleophile, it can be producer when there is weak nucleophile used. When there is weak nucleophile used when there is weak nucleophile used, then what will be condition? It will be undergo Sn1. When there is weak nucleophile, it will be undergo Sn1 reaction. Should remember that it will be undergo Sn1 reaction. Also it may be undergo E1 reaction. So it may be Sn1 reaction undergo or it may be undergo E reaction. E means elimination reaction and E1 means unimolecular elimination reaction. So when there is use strong nucleophile, what will be the case in case of strong nucleophile? In case of strong nucleophile, here this reaction will be undergo Sn2 reaction or E2 reaction. So these are the two differences, basic two differences between Sn1 and Sn2. When you use weak nucleophile, it will be undergo the reaction will be undergo Sn1 reaction. When you use strong nucleophile, it will be undergo the reaction will be undergo Sn2 reaction. I hope this point will be clear. So let's start different factors to comparison. Yeah, this is factors. This is the factor between Sn1 and Sn2 reaction. So let's start. The first factor is here. First of all, nucleophile. In case of Sn1 reaction, here will be weak nucleophile used. Very weak nucleophile used. While in case of Sn2 reaction, here will be strong nucleophile used. Strong nucleophile will be used in case of Sn2 reaction. Strong nucleophile will be undergo best Sn2 reaction, while weak nucleophile will be undergo Sn1 reaction, unimolecular substitution reaction. The effect of nucleophile, the nucleophile take part in slow step of the reaction. Nucleophile always take part in the slow step of the reaction. Yeah, in case of not here in case of is the slow step of Sn1 reaction. In Sn1 reaction, the slow step is without nucleophile. It will be without nucleophile because here is the weak nucleophile are used. Due to the weak nucleophile, the first step cannot be involved nucleophile. So in first step, directly ionization of the compound will be occurred. Means there is ion produced. That is one is cation and anion. Two different ions are produced. After that, the carbocations on this carbocation, the nucleophile will be the nucleophile that are the electron donating center of solvents. So the solvent will be act as a nucleophile and attack on this carbocation. So in first step Sn1 reaction, it will be slow steps on not nucleophile will use due to this nucleophile is weak nucleophile. So weak nucleophile will be undergo Sn1 reaction very best, while in when we use strong nucleophile in alkyl substitution reaction, so that will be undergo Sn2 reaction because strong nucleophile directly attack on the substrate and then replace the leaving groups. So that's why this strong group will be act as a the strong group will be undergo the Sn1 reaction, Sn2 reaction, the substitution reaction on Sn2 pathway. I hope this point will be cleared. The another factor is substrate factor. Substrate in both cases, substrate here in Sn1 reaction 3-degree substrate will be best substrate, means 3-degree alkyl halide will be good substrate. At well, when you use 3-degree alkyl halide, mostly this reaction, the reaction will be pass or undergo on Sn1 pathway. So is 3-degree will be very best for Sn1 reaction, while 2-degree may be undergo Sn1 pathway. While here in case of Sn2 reaction, when there is the groups on that are very sterically unhindered, so that's why this group will be undergo Sn2 pathway, where CH3X, which is methyl halide, it is very less sterical hindered. That's why that will be undergo Sn2 reaction very best as compared to the 1-degree alkyl halide, which will be and which can be undergo Sn2 reaction very best as compared to 2, but 3-degree alkyl halide cannot undergo Sn2 reaction, because in Sn2 reaction there is the collision of two molecules, and the first step that is nucleophile and substrate. So those nucleophile and substrate will be collectively, the collision will be present effectively when there is this when there is little bulkiness group present, means that when the bulkiness is minimized. So the reaction in which the molecule are sterically unhindered, that will be undergo Sn2 reaction, because here is the molecules of the collision of two molecules present. So when these two molecules, that is, let's suppose this is substrate and this is nucleophile plus nucleophile in first and rate determining step, these two molecules are react to each other. When the substrate and nucleophile are sterically unhindered, when they are sterically unhindered, the reaction will be, the collision will be better collision, the reaction will be better collision. So that's why those molecules that have sterically less hindered, like in C3X, which will be undergo Sn2 reaction very best as compared to the 1st-degree alkyl halide, that may be that up to less amount of it is sterically hindered, but it will be good substrate used, it will be good substrate used as compared to the 2-degree alkyl halide, that was be very poor alkyl, that was be very poor substrate in case of when we add strong nucleophile to this substrate, because 2nd-degree alkyl halide here will be sterically hindered, it produce steric hindrance to this nucleophile, so the reaction will be not effective. While 3-degree alkyl halide, this is very lesser, the ratio of Sn2 can be negligible, so that's why in 3-degree alkyl halide the Sn2 reaction cannot present. While in case of Sn1 reaction, as we know that Sn1 reaction, those will be good Sn1 reaction, those substrate will be undergo good in Sn1 reaction when they are sterically hindered, when they have strong electron donating group attached, means these 3 C3 are electron donating groups, so when they donate electron toward this carbon, that will produce effect of ionization, that will polarize this bond more, when the bond are become more polarized, so that's why it will become get easily to ionize, it will become CH3, CH3, it will become carbocation in first step and XV carbanion, and this is the rate determining step. So those reaction having more number of electron donating groups attached to the primary carbon, these compound will be undergo Sn1 reaction very fastly, because of, in this case, the carbocation formation will be very easily occur because carbocation is stable carbocation produced here as compared to the 2-degree alkyl halide. In 2-degree alkyl halide, the carbocation is not enough stable like in 3-degree alkyl halide or 3-degree carbocation. So those carbocation will be undergo Sn1 reaction very best that has more bulkiness, that has more number of electron donating groups attached. I hope this point will be cleared. The third factor is another factor is solvent effect. Solvent effect. Solvent effect in Sn1 reaction, those solvents will be able to speed up or to increase the rate of the Sn1 reaction that can ionize the substrate. So those solvents that can good ionizing solvent will be used in a Sn1 mechanism. Good ionizing solvent. We know that first step, that is the rate determining step of Sn1 reaction. In this step, ionization occur. So the ionization, when the ionization is fastly occur, so that's why the rate of the Sn1 reaction will be good. The rate of Sn1 reaction will be high. So that's why good ionizing solvent will be favored Sn1 reaction. But in case of Sn2 reaction, it have wide variety of solvents can be used. Different variety of solvent can be used. It may be strong, may be weak, but strong nucleophile can be act as a good Sn2 reaction. It will be Sn2. It will be pass the reaction under Sn2 reaction, under Sn2 mechanism. Wide variety of solvents can be used here. While in case of Sn1 mechanism, here only poor solvent will be used. Poor solvents are those solvents that have high ionizing, good ionizing power. It also means that those solvents that have high dielectric constant, it will be follow, in this solvent the reaction will be follow Sn1 pathway because the dielectric constant value means more the ionization solvent will be property, means when the substrate once ionized, it will be stabilized by the salvation power, and the salvation power is also called dielectric constant. More the dielectric constant, more will be salvation power. I hope this point will be cleared. The another factor is leaving group. A leaving group. In case of both, the leaving group will be good leaving group. Good leaving group. Priority will be given to good leaving group in both cases. This is the similarity between Sn1 and Sn2 reaction. In both cases, good leaving group required. Those reaction will be fastly reaction on Sn1 mechanism or on Sn2 mechanism, while the substrate containing good leaving groups that will follow the fastest reaction, that will increase the speed of the reaction. The another property is kinetics. Sn1 mechanism kinetically at follow first order reaction. Mean in the rate determining step. Here is only one molecule are used in most cases. So that's why it follow first order reaction. The first order reaction are those reaction in which the concentration, the speed of the reaction depend upon the concentration power rise to the power 1. While in case of Sn2 reaction, mostly Sn2 reaction are kinetically second order reaction. So it can be second order reaction, means the rate will be directly depend upon the substrate as well as a nucleophile. So these two molecules increase the order. Each molecule increase the rate. When they are double, the rate will be also double. So it means that the rate of the reaction will be on both molecules on each molecule will be increased to the power of 1, so the net result will be second order reaction, while in case of first order reaction the rate only depend upon the substrate. So these are the difference between kinetic Sn1 and Sn2. The another factor is stereochemistry. What is the stereochemistry of Sn1 and Sn2? The stereochemistry of Sn1 and Sn2: in Sn1 mixture of inversion, the product of the mixture will be inversion and retention. Mixture of inversion and retention produce. It means that racemization will be occur. Racemization in which the retention and inversion both have the same concentration, 50% of inversion product and 50% of retention product. So retention and inversion both product will be generate in mixture in the product, while in case of Sn2 reaction only inversion will be present. Here is only completely inversion will be present. It is completely inversion will be present here. I think this is very easy point, because we know that this stereochemistry of Sn1 reaction here is only here is in Sn1 reaction the product both can be formed. They maybe the nucleophile can be attacked from the back side of the leaving groups, or also can be attacked from the front side of the leaving groups. So that's why retention and inversion both product can be possible in case of Sn1 reaction, while in Sn2 reaction the nucleophile will always be attacked from the back side of the leaving groups. So that's why only inversion product will be also present. Also you can say that Warden product will be present, Warden inversion. I hope this point will be clear. And rearrangements, the another factor is the rearrangements. In Sn1 reaction rearrangement in Sn1 reaction here will be common. You can say here will be common. Sn1 reaction it follow rearrangement pathway, while Sn2 reaction here is rearrangement impossible. Here is not rearrangement occur. Why in Sn1 reaction rearrangement present? Because in Sn1 reaction there is the formation of different ions are produced in the rate determining step. So when first the carbocation generator in the first step, so those carbocation we already know that those carbocation will be good carbocation that have more stability. So for rearrangements, due to get stability, rearrangement will be occur, and rearrangement give to the stability to the compound. So that's why rearrangement can be present in Sn1 reaction, while in Sn2 reaction there is no ion formation occurs. So that's why here is no need of rearrangement. I hope this point will be cleared. Yes, these are about the similarities and differences between Sn1 mechanism and Sn2 mechanism. First of all, what is the difference between nucleophile, which nucleophile will be used in Sn1 and which nucleophile will be used in Sn2 reaction. After that the substrate factor, after that solvent, after that leaving group, after that kinetic, stereochemistry and rearrangement. These are the different factors that differentiate Sn1 and Sn2 reaction. I hope you all will be clear. If you have any confusion, you can also ask me in comment section. Also you can ask me in my personal WhatsApp that I drop in description box. You can get from the description box. And also please subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck.